Today, we'll explore systems of two linear equations in two variables, specifically how to determine the number of solutions they have. We'll learn how to identify whether two linear equations have one solution, no solution, or infinitely many solutions. By the end of this lesson, you'll know how to quickly spot whether the lines represented by the equations intersect, run parallel, or are identical. For the test, you need to be able to quickly identify these cases by looking at the equations themselves. To do that, let's talk about how the slope and y-intercept of the equations help us determine the number of solutions. In the slope-intercept form, m represents the slope of the line, and b represents the y-intercept, which is where the line crosses the y-axis. By comparing the slopes and y-intercepts of two equations, we can determine whether the lines will intersect, be parallel, or overlap. Here's a quick summary of how to use the slope and y-intercept to figure out the number of solutions. If the slopes m1 and m2 are different, the lines will intersect at one point, which means one solution. If the slopes are the same but the y-intercepts are different, then the lines are parallel, and that means there is no solution. Finally, if both the slopes and the y-intercepts are the same, the lines overlap, and that means there are infinitely many solutions. Let's see how this works with an example where we need to determine the equation of the line shown on the graph. Let's solve this step by step to figure out how many solutions the system has. First, we'll compare the slopes of the two equations. Both equations are in the form y equals mx plus b, where m is the slope and b is the y-intercept. In both equations, the slope m equals 2. Since the slopes are the same, the lines are either parallel or identical. Next, we compare the y-intercepts. In the first equation, the y-intercept is 1. In the second equation, the y-intercept is -3. Since the lines have different y-intercepts and we already know that the slopes are the same, we can say that the lines are parallel and will never intersect. Therefore, the system has no solutions. In this example, we need to solve the following system of equations. Let's solve this system step by step to find the solution, if it exists. First, we'll solve one of the equations for one variable. Let's take the second equation, x y equals 1, and solve for x. We have now x equals y plus 1. Now that we have x equals y plus 1, we take the first equation, which is 3x plus 2y equals 12, and substitute x with y plus 1. Then we distribute the 3, after combining like terms we will have 5y plus 3 equals 12. Subtract 3 from both sides, and divide by 5, and as a result y equals 9/5. Let's show the first equation on the graph. Now that we have y equals 9/5, we need substitute this value back into the equation x equals y plus 1 to find x. Then, convert 1 into a fraction, and like that we will have x equals 14/5. By showing the second equation on the graph, we can confirm that we have found our intersection point. The solution to the system is x equals 14/5 and y equals 9/5. Since we found a single point where the equations intersect, this system has one solution. In this problem, a theater sells tickets for adults and children. Each adult ticket costs $15, and each child ticket costs $10. If the theater sold 80 tickets in total and made $950, we need to determine how many adult tickets were sold. Let's solve this system step by step to find the solution, if it exists. First, we'll solve one of the equations for one variable. Let's start by solving the first equation x plus y equals 80, and solve for y. We now have y equals 80 minus x. Now that we have y equals 80 minus x, we take the second equation, which is 15x plus 10y equals 950, and substitute y with 80 minus x. Then we distribute the 10, after combining like terms we will have 5x plus 800 is equal to 950, subtract 800 from both sides, and divide by 5, and as a result x equals 30. Let's show the first equation on the graph. Now that we have x equals 30, which means the theater sold 30 adult tickets, we need to substitute this value back into the first equation y equals 80x to find y. Then, we have 80 minus 30, and like that we will have y equals 50. By showing the second equation on the graph, we can confirm that we have found our intersection point. The solution to the system is x equals 30 and y equals 50. This means that the theater sold 50 child tickets and 30 adult tickets. To confirm the results, we need to substitute both values into the revenue equation. The total revenue is 950, which is correct, so our solution is verified. Therefore, the correct answer is option A, 30. Well done. You've just completed a lesson and learned how to determine the number of solutions. Let's quickly recap the main points. In summary, you have to know that the number of solutions depends on the relationship between the two lines. We can have one solution if the lines have different slopes, they intersect at one point. In case the lines have the same slope but different y-intercepts, they are parallel and never intersect, which means that there is no solution. Finally, we can have infinitely many solutions if the lines have the same slope and the same y-intercept, which means they are identical and overlap completely.